Hello. Um, so today we're going to be talking about the Stacks programming language called Clarity and how it can help you to decipher blockchain data. I'm Jesse. I'm with the Stacks Foundation, and I am joined today by Philip from Arcadico. To jump right into it, what is Clarity? At its core, Clarity is a programming language that brings smart contracts to Bitcoin. Hopefully, everyone here is at least a little familiar with Clarity. There's a lot of interesting things about Clarity that we feel makes it a good language to use for smart contracts. At its core, it is a decidable language, meaning that you can know with certainty from the code itself what the program will do before you even decide to use it. This is possible because Clarity was designed to be an interpreted language. And that's kind of why we're here today is because of the benefits of human readable code, which Clarity employs. And the second part is really this, that every contract is published directly to the blockchain as a transaction that anyone can view and look at and even query if they choose to. So why was it created in this way? There's a lot of different reasons that it was done, but we're not going to focus on why it wasn't done. The reasons that it was done is we wanted to avoid some of the pitfalls and vulnerabilities that we've seen from other smart contract languages. The main one being with compiled code, it's very difficult to see what's happening with the code base itself. You kind of have to have a trust that the author is doing things that are good on the behalf of the user versus you deciding for yourself, I want to use this contract. I can see what's going to happen, and I have a reasonable expectation that things will work out well. So what are the differences between them? The main differences for Clarity are that, first of all, it has read access directly into the Bitcoin chain itself. And to my knowledge, no other contracting language has this. Obviously there are some things in Bitcoin itself that could provide this. The second biggest selling point is that it's an interpreted language. Similar to how JavaScript or other shell scripts are written and executed, Clarity scripts are executed exactly as you see them. There's no machine code, no compiled code to look at. What you see is what you get, essentially. It's also a decidable language. Given an input, a smart contract is guaranteed to end after a defined number of steps that you will know beforehand. In simple terms, you won't run out of gas fees halfway through an execution. There's also safeguards against overflows and underflows. So when a calculation is in a poorly written contract results in a value too large or too small than the expected output, the entire transaction is aborted. Post conditions. This is also one I get a lot of questions about. But a contract can also check that after a call completes, something that is expected to happen is verified. For example, if the post condition says that verify that 500 stacks were transferred and that didn't happen, the whole contract is reverted. There's also a built-in support for custom tokens. And we've seen this already with things like Miami Coin, New York Coin, and some of the other ones out there. Clarity also does not allow for re-entry. So at the language level, Clarity will not allow you to call another contract, and then for that contract to recall the first contract, triggering the same logic. And then the return codes, and to me, this is the one that's the most important because I love return codes, is you have to verify the return codes of every status. So something either is successful or it is not. And you have to check this. If you're not checking this, the contract cannot be deployed. So the reason we're here, human readability. And Philip can talk quite a bit more about how it was very useful for him in Arcadico. But we felt that it is the best way to design a contract language, specifically because developers can see the contract on the blockchain itself. It also allows developers to publish their code to GitHub, where anyone can look at it, they can borrow from it, they can learn from it. It makes it easy for people to learn the language and follow along with the logic that other developers are using. So today, we are recognized by GitHub as a language, and there's a lot of interesting contracts out there that you can search for today. So now I'm going to pass it along to Philip, who is a core contributor at Arcadico, one of the co-founders, and he actually wrote the contract that we're actually here about today. So Philip.
Awesome. Yeah, thanks, Jesse. So as Jesse already mentioned, I'm the core contributor, or one of the core contributors at Arcadico. And unfortunately, back in October, we did get an exploit in one of the contracts that I wrote. Never fun, obviously, to get hacked. But thanks to Clarity, it at least helped us create visibility around the exploit and debug the whole situation pretty quickly. And I do have a quick slideshow that I want to run through how we debug the whole situation and how we quickly were able to act thanks to the visibility and clarity, no pun intended, around clarity. That's a really bad joke that I think everyone should always make when talking about clarity. So I'm without further ado, I'm just going to share my screen and run you through the whole slideshow. And I hope this will work. Yeah, awesome. I think you can all see my screen. So today, already said it, but we're going to talk about analyzing the Arcadico hack. And so for those not familiar with Arcadico, we are first and foremost a stablecoin project built natively on stacks. Our stablecoin is called USDA, stands for US dollar Arcadico, synthetic dollar, meaning it's a stablecoin pegged to the US dollar. The special thing I would say about USDA is that it's over collateralized and yield bearing. You all know stacks the asset. You can stack your stacks in proof of transfer and that generates a yield in Bitcoin, right? But now you can collateralize your assets, your stacks tokens. We stack them as a protocol for you and give you that yield, but at the same time, you can borrow some amount of money against that position that you just collateralized. Our LTV, so loan to values, initially were about 25, 30%. And recently we've gone to 50%, meaning for every $2 in stacks tokens, that you collateralize, you can mint $1 in USDA. Soon, probably as early as next week, we will, put those LTVs even higher to 70 to 80%. The reason being is it's becoming more efficient to mint and liquidate some vaults, but these are technical details. The point being is that it's becoming very efficient to create and mint some USDA, some of our stablecoin. And so I want to add some quick nuance that in fact our stablecoin was never hacked, but we have two products, and one product is our stablecoin. The other was or is, since we still operate and it's completely safe today, but back in October, our swap wasn't completely safe. And unfortunately, we only found out, during or let's say after the hack. So again, I'm Philip, and you can find us, by the way, in Arcadico Finance on Twitter if you're interested in following us or knowing more about our stablecoin and how it works. But here's that important nuance. So while we focus about 95% on our stablecoin, which is our, as they say in French, raison d'etre, this is the reason that we live for our stablecoin. Unfortunately, the additional piece of architecture of infrastructure that we deployed, the swap, in other words, it got exploited. The reason we focused on both a swap and a stablecoin in the early days was because Stacks as a blockchain, as an ecosystem, was growing rapidly. But when we wanted to release a stablecoin, there was no swap yet. These days, you have Alex Swap, you have Stack Swap, you have amazing swaps, and you also have Arcadico Swap. So there's a multitude of choices where you can, exchange liquidity, exchange your tokens. But back in October of last year, unfortunately, those options weren't there yet. So we released both a swap and a stablecoin. And so for those not completely familiar with what a swap, or a decentralized exchange, through what is called an AMM, an automated market maker. For those not familiar how that works, I'm not going to, go too deep in it, but the basic idea is that you build pools of tokens. So it doesn't work as in traditional centralized exchanges where you have order books. Here you have pools that need to be kept in balance. Usually they're 50-50 pools, and we launched a Stacks USDA pool, meaning you can, if you want to post liquidity on it, you can do that as a user. Anyone can post liquidity and get, we in fact incentivize it. You get tokens, you earn yield by posting your liquidity. And so that's what's called a 50-50 position. Usually for 50% of the Stacks value, you post the same amount in dollars and USDA. So it's balanced equally. And for that position, when you deposit it on Arcadico, you get LP tokens. And those LP tokens, they represent your 50-50, well, initially your 50-50 AMM position. That might, change, right? As the pools go up and down, it's not automatically rebalancing. So one side, the stack side or the USDA side might become worth, or the other might become less as people trade in those pools. But initially you post a 50-50 position that gets represented by your LP tokens. LP can be freely translated for liquidity position. It's called just like that to represent your position. And so on that unfortunate day of the 27th of October, you can see the timestamp here. I got a message from one of a great ecosystem community person, very active in the community, and he messaged me on Discord and said, "Look, Philip, I think something's going wrong on your swap." And obviously in the height of a bull market, you get tons of messages, right? But since that guy was such a well-known community member, I was like, okay, let me have a look at this. And so a person or a group, we don't really know who exploited Arcadico or who hacked us, but they deployed a contract called Defiant White Bobo Link. And so that was deployed as of today about 6 months ago. And that was on the 27th of October. I'll go and run through it in the Stacks Explorer later. But the important thing to see here is probably the name, Defiant White Bobo Link, which is quite interesting because for me, that's an indicator, and it doesn't have to be, but it usually is, that the contract was deployed through the sandbox on the Stacks Explorer, since it automatically generates those kind of funny random names for you. This is not necessarily a signal or anything to do with it. It's just like something interesting. The next time you go to, for instance, explorer.stacks.co and you see something like white dirty rabbit or something like that, you probably know it was deployed through the Stacks Explorer. Don't ask me why those words came out, but it creates these random funny contract names. And so I was like, obviously the first reaction when you see this is like, holy crap, we are in fact getting exploited. And you know that pretty quickly, because everything that happens, every token that gets minted, burned, transferred, or manipulated, let's say in general, is visualized clearly on the Stacks Explorer. I call it gibberish because there was literally a ton of gibberish stuff going on in the contract itself. Which caught me off guard initially. You can see a lot happening here. This person, let's call them the attacker now. The attacker mints novel token 19. They transfer it. They also mint some NFTs in the attack, probably to confuse us when analyzing the data, and then to make it a bit harder for us. And then they transfer 2 tokens of a huge amount, 200,000 and 400,000, with the name D. They're fungible tokens. They don't have any use. The attacker created those fungible tokens, in fact, a few hours before the actual attack. But so those are some of the events that happened when executing the attack. Those are not very useful on their own. They're more of like almost a distraction, as I said, but nonetheless, there was a lot of gibberish going on, and you'll see in a few minutes why I think for the attacker that was relevant. Moving on, what the attacker did in the attack was they added liquidity and then they immediately removed it. And that's really interesting. And again, I'll show you that in a minute. But after that, they transferred and they drained one of our pools, the Stacks USDA pool, for about 209,000 stacks and almost 400,000 USDA. At the time, if you calculate this quickly, then at the time you could calculate that Stacks was trading at about 1.9, since the values have to be equal, so almost 400,000 USDA versus 208,000 stacks. My math could be off, but the point is the value should be equal when you're removing liquidity from your LP pools as well. And so they drained that. If you calculate this quickly, that's about just a little less than $800,000 in value. Which is pretty rough to take as well when you're sitting there. It's not like 20 or 50 or 100 million as you see in some, unfortunately, in some other DeFi hacks, but it's still painful. I have to add the caveat that luckily none of our users have lost money, because part of the gap we covered with the Arcadico treasury. So we lost, unfortunately, also about $500,000 to $600,000 in that hack, but that all came out of our own pockets. You know, we completely made our users whole. So there was no real damage done, and then we could recover due to a pretty interesting trick. We could recover the USDA, so only the stacks was lost, fortunately or unfortunately, but those stacks were sent to a centralized exchange. We never recovered those. But so before I jump into the Explorer, let's review. So we had an AMM, anyone could add a pair to that AMM. It's completely decentralized and permissionless. This is very important because that's how the attacker executes the exploit. The biggest mistake I think here was that our LP tokens could be used multiple times. So when you add a new pair, in this case, Stacks USDA, you also introduce another fungible token that I talked about, the LP token. So there's 3 tokens when talking about a pool. Token A and token B that have their balances in the pool, and then the LP token, again, that represents your position. Something that we did not check for, which obviously in hindsight is very dumb, but an LP token, as it represents your position, it should never be used in another pair. And so when you know that anyone can add a pair to our swap and LP tokens can be reused, what that person did was the attacker created a new pair, token D and token E, let's say, but they reused the correct LP token. And so they just made a huge pool. As you could see here, they made a pool of hundreds or millions of these D tokens. So token A and token B, in this case, as I said, it was a huge pool, but with an existing LP token. So it minted a ton of those LP tokens, and then he immediately withdrew them. But those LP tokens nonetheless were minted. They were the correct tokens. And then the attacker could go to the real pool after that with all the now real LP tokens that they minted from the fake pair and withdraw all the liquidity. So to summarize, he created a bogus pair with an existing LP token, and he allows to create millions or billions of that bogus fungible token, mint the valid LPs, and then burn those LPs on the real pool, withdrawing all the value, which is no fun. But so now I want to jump quickly into the Explorer and see, what those screenshots look like when you go to the actual deployment of the contract. As I said, it's Defiant white Bobo link. Here you see all the events of minting the fungible token, transferring it, the NFTs, DD. And the way Clarity helped us in this case is that, as Jesse mentioned in the beginning, it's all interpreted, which is super helpful in this case, because you can go to the exact function and the exact line that the attacker executed to know how the exploit was done. And so in our case, if you scroll down, by the way, on any contract on the Stacks Explorer, you see the source code. And the funny thing is, when you go through the source code in the beginning, we can quickly analyze it. He defines some constants, sender and a receiver. He defines a fungible token, the novel token. He mints some, he transfers some, as you can see in the events up top that we went over. So the mint and the transfer was done. Then he creates a fungible, non-fungible token, so an NFT. They mint some, they transfer some. There are some standard, public methods that they don't use, a map. It's all like worthless code between quotes. It's the code on its own like this, it doesn't do anything. So you'd be like, where is the exploit? You might be thinking, because there's other events such as the minting of those LP tokens, W stacks USDA, for instance. He minted a ton of those tokens. And when you just look at this code, you don't see anything. And so funnily enough, you can scroll horizontally as well. It's kind of, we spent like 10 minutes looking at this, or maybe half an hour. And like, I can't find anything until we thought, okay, let's scroll horizontally. And if you keep scrolling for a while, all of a sudden you see some more code here. And here he in fact calls the Arcadico swap. He creates a pair, as I said, with one bogus fungible token, crowded olive elk, and another one. So this is token A, the crowded olive elk. Then the token B is the ugly copper raccoon. But then, as I said previously, he used a real LP token. So he added a ton of liquidity. As you see here, he added about 200,000 of token A and about 400,000 almost of token B. This is 400,000 and this 200,000 because these are 6 decimals. So you have to divide by 10 to the power of 6. So cut off the last 6 digits basically to make this human readable. So 200,000 and 400,000 added to liquidity. As a result, that amount of LP tokens again was minted, and then immediately they reduced the position, as I said, but on the correct pool, stacks USDA. But since that person had that insane amount of LP tokens that represent your position, the protocol and the code thought, okay, this is legit because this person has those LP tokens, those real LP tokens in their wallet. So let's send them the stacks in the USDA, which, well, is true. It's all valid, but unfortunately, well, of course, we didn't want this to happen. So he withdrew all the liquidity. And once we knew that, we knew we were in some trouble, let's say, once we figured out, okay, the horizontal scroll here. And so I think I think Jesse and myself can talk a bit more about that. But how this helped us was obviously identifying this really quickly. And then it starts, right? Then you need to start debugging, thinking for how do we solve this? Unfortunately, everything was decentralized and permissionless, so we couldn't just turn off our swap. And ultimately, I think we were up from like 8 p.m. when I first saw the hack until about 4 a.m. And we didn't find a better solution than executing the exploit against ourselves, draining all the value, which was about $10 million at the time, and then reconstructing the swap with a fix and all the liquidity in it again. So we essentially migrated all the liquidity onto a new contract by executing the exploit itself, because the choice was, are we going to wait and go to bed? Obviously, you don't do that because the attacker might still be there, because he didn't withdraw, luckily, all of the liquidity. As I said, there was about $10–50 million in it, and he only withdrew about 800K. So we knew we needed to take action, and yeah, that's what we did. Pretty hectic night, still no fun, but as I said, no one lost money, luckily, and except for the protocol, as I said. And yeah, Clarity helped us tremendously there. So that was a lifesaver. That's all I have to say about the hack for now. I think, yeah, if there's any questions from the audience, happy to take those, and we can go from there.
There was actually one question. Let's see, it's from Gabor Kovacs. The question is, since the stacks was sent to a CAX, wasn't it possible to identify the hacker?
Yeah, good question. It's interesting. I can go a bit into this. It's a whole legal process that you have to start. So when you get hacked, when any protocol, by the way, gets hacked, they can't just go to a centralized exchange and say, give us those tokens back. Because who says you are the legit owner of those tokens? Exchanges cannot just send you tokens back to anyone. I mean, yes, that contract had those tokens at some point, but who says that code, you know, for better or for worse, we call it an exploit, but maybe that was intended behavior or maybe not. You don't know, right? Only humans you know, can deduce, let's say, what the code is supposed to be. And so, of course, that was sent to a centralized exchange and we knew what the exchange was. So we immediately got in touch. We also got in touch with the authorities. We filed a police report. The assets were frozen and all those things happened. And then you go into, you can go into further, I guess it's a suit, let's call it like a lawsuit or something, or you can just, you know, cut your losses and say, we have to move on. We opted for the second option because it was tremendously hard to get any information on the attacker. So in this case, they sent the token to a centralized exchange, but they used a proxy to do that. So there's a third-party service where they didn't need to KYC. Fortunately, there is no KYC information. Some countries still don't require that. I'm not saying I'm pro or against KYC. I'm just saying some don't have it. And they gave us some IPs. They were IPv6 addresses that led to a Tor endpoint. So that wasn't very helpful either. They also gave us an email address, but it was a generic email address that said, hi, Arcadico at protonmail.com. So the attack was, you know, pretty well prepared and pretty well executed. So yeah, it's not as easy as just going to the centralized exchange and saying, please give us the tokens back and all as well. It's very complicated legally.
Excellent. So it sounds like you had a hard time trying to figure out who it was, and they were prepared for this.
Yes.
And yeah, in my experience with hackers, that's usually the case with the good ones. Okay, I don't think there. Oh, looks like there may be one more question. From Jacob. How did you recover the USDA?
Yeah. So through a governance vote, we were able to burn the USDA and then remint in a wallet that we owned, and then we just burned it ourselves. So you can, on your contract, you can add mint and burn functions, right? And only our stable coin obviously can only be minted through vaults. But there was a backdoor that through governance, we could instate, and that was temporarily, by the way, that we could instate the DAO to mint and burn some of our protocol tokens. In this case, that would be the Arcadico token and the USDA token. And so temporarily, because I have to add a nuance. This is quite tricky. If you launch a DeFi protocol, you cannot be 100% decentralized from the start. It's very difficult. It's not easy. And so that's why we had this little backdoor that allowed us to burn and mint the USDA again. And so we used that through governance. And long story short, that's how we recovered it, through a technical trick, basically. And now we have moved on from there. This trick, if we would ever get hacked again, we would not be able to recover those USDA anymore. But luckily, it was the beginning of our protocol, and then that was possible. So yeah, happy to dive into details. If you, I can link you to the contract if you hit me up on Discord, if interested. Happy to.
I have a question for myself, actually, for Philip. how did you guys come about the decision to use the hacker's contract to recover the funds or to stop the hack, essentially?
Yeah.
I mean, that seems very interesting to me.
Yeah, definitely. That's a good question. So in the heat of the moment, you need to think clearly, right? The most important thing is to stay calm, and there is no perfect solution. Knowing that you can't just switch off, the liquidity, because if I can switch off liquidity with a private key or even a multi-sig setup, then it's not truly decentralized. So anyone can add and remove liquidity at any point. So for us, it was no option to turn off liquidity because that option didn't exist. So that option was off the table. And then you think, with the smartest people that you get on a call and you list all the options. And what options were there? We only saw two viable options. One option was selling so much USDA into the pool that you would essentially take out all the stacks as well. So it would become really costly to incrementally, get more stacks through a trade. Imagine we were able to get our hands on, let's say, $10 million in USDA, then we could just dump those in the pool, off balancing the pool completely and taking out all the stacks. Essentially, you just do a trade that is very unprofitable for you. But we couldn't get our hands on those $10 million of USDA because we didn't have 10 or $20 million of stacks laying around. So we called up one of our investors and we said, look, do you have $10 million in USDA? And obviously that's a bit of that's a big ask, right? You just get hacked and you ask your investor to to give you $10 million to drain your own pool. It wasn't feasible. It was just completely understandable that it is too hard, especially in the heat of the moment. So there was only one option left, knowing that we couldn't trade against ourselves and get all those stacks out of the pool, and we can't turn off the AMM. Then the only option for us was, do we pull the trigger and launch the exploit on our own contract and recover the funds? And really, I think in hindsight, that was the best thing we could have done. We should have probably done it immediately. Luckily, no more funds were stolen, but yeah, those three options were there, and you just need to analyze them, and knowing the trade-offs, right? There's always going to be trade-offs, and so in the heat of the moment, I think we did make the right decision of trigger the exploit.
Sometimes the scariest option is always the best one in hindsight.
Yeah.
There are a few more questions, but let's hold off on those until the end, I guess. So continuing on, we heard about one of the bad use cases for human readability, and that Arcadico and Philip had a hack. But there are some good reasons to have human readability as well. The first one is developers are disincentivized to publish bad code. So myself as a Clear developer, if I'm creating a contract, anyone else in the world can see this contract. As Philip showed us, he could read the contract that was deployed and he could figure out what was happening. And if I deploy, something that's written very poorly, it's going to reflect on me. So in that way, developers are incentivized to craft good contracts, ones that people will like and use. The second one is actually from the foundation itself. So after Bitcoin, the Bitcoin Unleashed event in Miami, flying back to California, I had a bug report come into our bug bounty program with Reunify. And this one was dealing with some NFT contracts. It was a very interesting edge case hack. Ultimately was out of scope for the foundation, but we could go in and look at the contract, see what they're talking about, and verify that, yes, this is definitely possible. And then reach out to the contract owners themselves and say, hey, this is what happened. This is how you can look at to fix it. And it was very, it was hard to find the people because of the nature of blockchains, obviously, but, we kind of knew who it was. So it was very easy that way. The next one is everything is verifiable. So, in comparison to other smart contracting languages, I don't have to trust that a contract I want to use is going to do something to my benefit. I can look at the contract and verify it for myself that yes, this looks like it is correct to me, and I'm going to use it and run it. It's basically you trust the code versus trusting the person, and that's what a lot of us are in blockchain for, is trust the code, not the person. Yeah. So moving on from that, about human readability, what is Arcadico learn from this, and like, what are you guys doing to try to prevent other issues like this in the future?
Yeah, I think one learning is that maybe this is very clear in hindsight, but you are actually incentivized to open source your code as soon as possible and go to the community for peer feedbacks. On some other blockchains with let's say compiled languages where you can hide your code, there is less of an incentive to open source it, because you can hide it forever, technically speaking, if people can only access some bytecode or whatever it is, right? Or not even maybe, then what's sometimes the point of open sourcing your code? So I would say, while I think we did involve the community very often, I think involve your community the earliest as possible, open source everything. And in fact, everything around Arcadico was open source, but you need to sometimes push and ask for people to review some of the code. Yeah. And I think perhaps if we had done that, maybe some of those things could have been caught. That's one big learning that I say I would do, incentivize open sourcing sooner.
Yeah, there's actually a really good blog post by Hero about how with the clarity there's no way to hide. And as we saw from Philip, like with human readable languages like Clarity, the only way you can hide it is really to obfuscate it, which is to try to kind of hide it from the viewer. So as you saw, Philip had to scroll sideways for quite a while to see what was happening. And that's one of the tricks that people use. The other one is, just try to make it as hard to read as possible, which is not easy with a language built around Lisp like Clarity. So now that we know what you've learned, what can the rest of the community learn from this event? Like, what are some best practices that you would recommend to other people new to the space?
Yeah, I was just going to say best practices are super important. And these days, there are amazing community members who create GitHub repos with all best practices, even in Clarity. There's this guy, and I mention him almost every time I speak at an event, but this guy called Now, and he has an amazing, set of best practices and guides on how to find issues in your code. But perhaps Jesse, I can send it to you and we can share that link to that GitHub repo somehow with the notes or something. But I guess generalizing, usually hacks that I've seen in Clarity happen through input parameters. So especially or specifically traits. So whenever you have an input parameter on a public function, think of permissions. Who can call that function? What could potentially go wrong with this input parameter? How can people negatively use this input parameter? Again, especially when it's a trait, anyone can implement a new contract that adheres to that specific trait that you created. So could anything be drained by inputting a malicious trait or a malicious implementation of that trait, I should say? So these are always my first thoughts when I talk to new Clarity developers, is go over all your public functions, especially input parameters, and see what can go wrong. Because I have rarely seen, well, I haven't seen many hacks in Clarity first, I should say, only one really, ours. But that was through an input parameter on the trait. And second is the use of the keyword as contract is very, very powerful. but it should be used with responsibility, because essentially S contract changes the scope of execution, and it allows you to transfer tokens that are saved on the contract that are otherwise not accessible, that are now become accessible when you change the code, change the scope of your execution. So these two things, input parameters and the S contract keyword, are my go-tos when I look for vulnerabilities or weaknesses in code.
Excellent. Before we transition to the Q&A section, I just want to ask for you and Arcadico in particular, what's on the horizon? Anything new that we should be looking out for you guys?
Yep, definitely. So I mentioned our stablecoin is super important for us. We recently launched what we call a liquidation pool. So essentially you're borrowing against positions, right? And unfortunately, sometimes people need to get liquidated, a margin call, in other words. And so before, those used to be auctions, and then they were very privileged because you can buy stacks at a discount through those auctions. It's about 10 to 13% of a discount. And so before, it was really a bidding war. Whenever a vault got liquidated, everyone wanted to get their hands on those stacks, right? Because they have a discount of 10% against the market, which is a 10% instant profit. And some vaults can get pretty big. Like, we had liquidations of vaults of 50,000 stacks and over. That's about $50,000 and higher in today's value. So once those get liquidated, those represent big opportunities for almost, let's say, professional arbiters that want to get access to those stacks. And so what we have implemented is we made this more universal and accessible to everyone. We implement a liquidation pool, and you can simply put your USDA in there, and vault liquidations now automatically, and everyone gets their share of those stacks tokens at a discount, pro rata the amount of USDA to put in that pool. So we're continuously trying to innovate and make our protocol more efficient. That's one thing. And I think on the horizon, what I'm looking forward personally is a stable swap. So a second stable coin launched with XUSD, which is a wrapped USDC. And this really helps expand the ecosystem. It only makes USDA stronger. You will be able to borrow, and lend and borrow USDA in the future on multiple ecosystem protocols. So that's, in short, what's on the horizon for us. Mainly, we want mainstream adoption of USDA to happen and become the dominant and decentralized stablecoin on stacks.
Awesome. Very exciting. So I guess we'll start doing the Q&A, and I may have done Hopin a little incorrectly. So I'll try to find all the questions in all the chat windows here. So starting off with Jack, has this attack changed your view at all on keeping contracts permissionless? Are you now more inclined to introduce backdoors into your contracts?
It's a tricky question, but as a DeFi developer, you certainly, I certainly became a bit more conservative. But it's a very slippery slope, right? Because why are we developing in this space? To make everything more accessible to, let's say, a more retail crowd, and to create this open finance system. But if we're gonna start adding backdoors to everything again, then what's the point? Then you just have recreated a traditional finance system on a blockchain, essentially. So it's very important not to go there. And so whenever we add a backdoor on our contracts, we put a limit in block height on that. So we say we launch a new feature and we would love to have a backdoor. Then we say, for instance, they were at block height 58,000 something. This backdoor is accessible, and that block is hard coded. It's accessible for the next 5,000 blocks, which is approximately, 50 days or whatever. So we know that the first 2 months, let's say, we have that backdoor in case something goes wrong. Because when you launch something, those first 2 to 3 months, they're quite crucial. A lot of money will pour in because people test to a real value, and that's that's a big honeypot that you're essentially created. Right. So you want some kind of centralization, but not so long that it is forever centralized because of the problem, the challenge that I just explained. So yes, think of this, but please don't, don't start building backdoors everywhere, because it just ruins the ecosystem, in my opinion.
Yeah, bigger surface area for hacks as well, with more backdoors. The next one is from Travis. What are Arcadico's thoughts on an insurance protocol that would protect against smart contract risk?
Yeah, I mean, it's great. And on alternative blockchains, you definitely have such protocols. I do think it will come. As you know, as in the next 5 years, we will see a ton of liquidity and money pouring into stacks. There will definitely be an insurance protocol that will launch. I'm convinced that it's not an if. I'm more convinced that it's a when. As soon as we have like a few billion in TVL, we just need to ask when is this insurance protocol coming? Because it will come. Anything that has
anyone listening, it's a great idea.
Free startup idea.
Yeah, absolutely. Following up on that, do you guys have any kind of bug bounty program for your contracts or your open source code?
Yeah, we do. So there's a link to our security pages on the app. It's also on GitHub. So yeah,
outstanding. Okay, so moving on, Jacob asks, no, that's not a question. That's a great comment though. You should probably read it. Okay, Nat is asking, are there any plans to have clarity tutorials added to sites like Code Academy for interactive learning of the language? Yes. So the foundation is always working with different people and organizations to integrate with and get the message of stacks and clarity out there. Something like Code Academy should be coming soon. I can't comment more than that if it's not public. But yeah, just keep your eyes open on Discord, the announcements channel, and as soon as something is official, that's where it'll happen. I think that's all the questions. Let me go back to the other channel. Yeah, I think that's everything. Unless anyone has any more questions you want to throw at us. I'll hold on for a minute. Okay, well, Philip, thank you very much for your time today. It was great to hear about how you guys handle this. Security is something I'm always interested in. We also recently launched our own bug bounty program for the Stacks blockchain, and incidentally, some of the core contracts itself, like POX. So, learning about how you address this has been very enlightening, and I appreciate your time.
Thanks for having me.
Absolutely. All right, take care, everyone.